Good afternoon, everybody. Hello. Thanks for coming. Some of you sent me messages about which problems you'd like me to attempt, and I'm going to handle them in order, and then I'm going to look at the last exam of the exams. So you can ask me questions as we go like we did last time if that works for you. If it doesn't, if that doesn't work for you, let me know. You can hear me? Everyone hears me? I'm just setting something up. Do you hear me? Hello, hello? Okay, very good. So usually you'll find you're getting the hang of my labeling. You can find the videos as the labels, but I didn't create the link yet, so I was a little slow doing everything today. Okay, so let's see. Heike asked me to look at the oldest midterm, one of the older ones, and to attempt questions 17 and 22. So I'm going to do that. So 17, oh, this is the old midterm. This is it here. Seventeen. Aha. So this is like the this is like, well, this is a weighted mean problem. Okay, they've given me frequencies and they've given me values. All right, so you see these are the values. This is the variable, right? The number of errors. So that's the value of the variable. So you have to distinguish between the values and the counts. So this is like, these are like the frequency. This would be like the count, right? The number or the frequency. And this is the variable up here, x. Ugh. It's supposed to be an x. Okay. So to find the mean, we're finding the weighted mean. All right? So I don't know if you guys want to try that, or if you want to anyway, just give it a try. I'll give you 2 minutes. All right, so 5:11, I'll check back with you. You can write me, you can text some comments if you like. Okay, did you do something? So what you have to do is you have to multiply the value by the number of observations. Okay? And if you don't know how to do this, or this looks like very foreign to you, look at those questions on the those problems, exercises. There's 3 exercises on the weighted mean in the GDS unit. I made videos and recognize that you have to do a weighted mean. Each observation, these are the observations, each observation has different significance. So rather than making a list like a ranked list that looks like 0, 0, 0, you know, no, that didn't work. Anyway, 0, 0, 0, 0, 0, 0, 102 times, and then 1, 1, 1, 1, 1, 1, 138 times. So rather than doing that, the data has been presented in this table. Okay? So we have to adjust for that fact. When we calculate the mean, we're going to take each observation, or each possible value, multiply by its frequency, and then add to the next one. 1 times 138, which is just 138, but you get the point, plus 2 times, so I could put brackets if this confuses you. It shouldn't confuse you because we work with the order of observations, order of operations, sorry, and keep going. 3 times 79, okay, plus, I'm going to go into this space here, plus 4 times 33, plus 5 times 8. And we're not finished. All we've done is basically, rather than, like I said, rather than adding like all these together, okay, and then dividing by the total count of them, we're going to do it this way with multiples. So there's 102 zeros, 138 ones, 142s. See, this is the idea. We add them together and then we divide by how many there are, and it tells you there's 500 pages. And that will be your average. Okay, so that's how I presented the data more efficiently, and you need to know how to use that presentation of the data to calculate the weighted mean. An alternative would be to find the probability or the proportion of each of these values, the proportion of them, and pre-multiply each value by their weight. But see, I didn't have to do that. This is way easier. That is much more complicated. So I didn't put them together, but I guess I should, because I can't count on you guys to do that. I have to, well, I mean in the sense that you're counting on me to do it, right? So I guess I should do it. So this first one, this is just 0. So then there's this, 138. And then there's this, which is okay, so this calculator, the TI calculators don't use order of operations, so you're going to have to use brackets, right? That I presented them here. So it'll be 138 plus 2 times 140, close bracket, plus bracket 3 times 79, close bracket. Now, if you practice with Excel, this should be easier. If you want to know how to do that, let me know. and I can demonstrate. What kind of answers are you guys getting? 827 is the total? Okay. So Heike, Chloe, they're both picking B. Is B the correct answer in the options, Heike? Is it the correct response? Yeah? Okay. So it looks like B. Practice, do it a couple of times. You might have made a mistake. Make sure you get the same answer at least twice. Okay. So the answer is B in the back? Okay, so it's B. Very good. All right. The next one that she asked me to look at, I'll save this. Was 22. If you notice in the description of the videos, I always put the timestamps so you can just click around and see when you want to review this, you go directly to the problem that you were interested in. So then you ask for 22. Okay. So again, remember I'm using the old exam. Let's go to problem 22. This is 2012 October. 22. Aha. All right. So now you have to keep in mind what the box plot does. And again, review those videos. If what I'm telling you is brand new, then you need to review those videos. If it's repetitive, then you don't have to review them. Just try and remember this is how you look at box plots. So here you have the data divided into quarters. So 25% of the observations are here, 25% of the observations are there, 25% are there, and 25% are there. So that means, well, there's 120 students, but if there are 100 students, then 25 would be here, 25 would be there, 25 would be there, and 25 would be there, and they're sorted in a numerical order. So in this case, we have 120. So that means at 40 is, basically out of 120, you got to take off the first 25% to know how many students were above 40. But basically, since it's exactly here, and we know this is a 25th this is the 25th percentile. This is the 50th, this is the 75th, and this is the 100th, then this tells you 75% of the students are above 40. So 75% are above, 75% of the students are above. So to calculate how many, you just take 75% of 120. Whenever I say the word of, you always multiply, okay? That looks like an X. Let me fix that. You multiply, okay? Of means multiply. So 75% of, not sure why it's flashing on and off, but bear with me. Okay, so what's 75% of 120? Yes, you're going to see lots of similar questions. So that's why you have many exams, to see the patterns, see the similarities, and gain confidence. Okay, so try all the exams. So 75% of 120 means 0.75 times 120, and it is 90. So the answer should be D. Is that correct? Any questions? I'll save that. I'll wait. Any questions about it? I'm just saving them in case you ask me to go back. Could you explain it again, since I wasn't able to see? I didn't understand. All right. So that's it there. So have a read. We'll read the problem. Approximately how many students scored above 40? 40 is here. Right here. That marks the 25th percentile. So that means 25% of the observations are here, and 75% of the observations are here. The question is, how many students scored above 40? So I'm asked about how many students are here. 75% of the students are here, so I just multiply 75% times 120. When I do that, I get 90. So 90 students are here and 30 students are here. Okay? Okay, then we have questions from Caroline. She sent them. Caroline sent me these questions. I guess she got them from exams. So why don't you try that? I give you 2 minutes. Okay, if you didn't get the answer yet, let's just talk about what the answer could be. So it's 69, sorry, you're picking 6 numbers from 69, right? Now, so this is a little tricky in that you don't really have a list. You just know the numbers of the lists that you would have. Oh, sorry, you're going to use 49. 6 from 49. I don't know why I said 69. All right, you want to pick 6 distinct numbers from 1 to 49. So the last label is 49. So that is why you take pairs of digits. So you take two at a time, and to do that, you're going to say, you can divide it like this. I'm going to make it a little bit bigger. It might be easier to manage. And I'm going to do this for 6, right? Whoa, I don't know what happened there. So make this a little bit bigger. So this is going to be 66. That's not in the list. 83 is not in the list. 16 is, so that's going to be 1. That'll be the first one. So be careful about the ordering, because they don't necessarily give you the numbers in order here, do they? Anyway, we'll see. 89 is the next one. That's not in the list. 8 is, so that gets chosen. So 16 and 8. So you see, it's actually showing us that B and E are in the running. Look, they have the same. So we have to go all the way to here to know the difference, which is the right answer. So let's continue. 47, that's a number 2. 72 is not. 22 is. And 16 was already chosen, so it's not. 58 it's not on the list. 47 is on the list, but we already used it. 78 and 13 is the last one. So that's all I needed. So this is the answer. E. Very good. Very good. Some people got B. You got to keep going to know it's going to be 13. The second 16 you ignore because you already chose 16. There's the trick. All right. So I'm going to save that for now as problem number 1. Okay, let's look at the next one. I have to go back. And let's go below. So finally, it's going to be one of our first design problems. So let me have you look at that for a moment. I'll give you a couple minutes to read that through. So about that problem, some of you are asking me about repeating, if you can repeat numbers. No. Well, I know what you're saying, I guess, if you're asking. And obviously, if we're picking individuals, we can't repeat. If we're choosing them for a survey or to be part of a study, we can't repeat the same person if we were to choose them twice. In terms of the lotto, on the 649, I think it's the rule you only pick one. I guess it doesn't say that. So if you argued that and you picked that other answer. Unless I was clear, I guess I would have to give it to you. So don't worry about misunderstandings like that. But essentially, yes, you have to look at how the problem phrases the question. I think that the audience reading about that, like the students reading that question, knew what the 649 was, so they didn't they didn't think that you could pick the same number twice. I can verify that, but I'm pretty sure you can't pick it twice. Okay, so if it's not clear, then you can definitely complain, and I'd give you the points for that. Yeah, 6 numbers have to be different. Okay, yeah. Okay, so for this problem, very good. Heike, anybody else? So this problem has 3 factors. There are 3 factors: the frequency of watering, the type of plant food, and the exposure to light. And we're going to combine all the possible factors, all their levels. We're going to combine all the possible factor levels. To do that, we're going to end up with, well, there's 3 levels here times 2 levels here times 4 levels here. So the answer is 3 times 2 times 4. So the answer is 24. And there is a formula for that in the notes. After I talk about the physician health study, I explain how you figure out how many treatments there are. In the physician health study, there were just 2 factors with the 2 levels, placebo or not placebo, right, of both beta-carotene and aspirin. So it was 2 times 2, and in that case you had a box with 4. In this one, you'd have a matrix with, well, actually it would be 2 matrices that are 3 by 4. We did discuss that as well in class. So you would have 24 different treatments. Any questions? Do you want me to explain that some more? Okay, so let's see. Let's try the more recent exam, the 26th, October 2019. This one. All right. Okay, so tell me which topics you'd like to see of the 4. DNS. You like to see DNS or GDS or NOR or regression. We spent a lot of time on regression. We did a lot of GDS. NOR, I'm hoping you understand that, but anyway. let me know which areas, which questions you'd like me to capture or cover. Sure. I'm here, Nor. I just see Marlene says Nor. Okay, let's see, I got some Nor. I have some Nor for you. More regression, oh my goodness. Okay, I really need you guys over the next 3 days to hunker down and do all these problems so we can be more specific about where you need help. Okay, so what I can do is I can show you the problem here. So this is from the second last midterm, October 26th, I believe. Just gonna double check. Yeah, this is from October 26th. Okay, and they give you information. So this is, okay, so it generally, I laid it out in class that one time. I don't know if I really got into it, that there are basically 4 types of problems. Really, actually 2 types of problems in NOR. It's just where I ask you to find the probability of certain outcomes if a variable is known to be normal, and then the backward problem where I ask you, given the value of an outcome, given the probability of seeing a certain outcome, what is the outcome? It's a backward problem. So I can do that if I talk about a normal distribution or a standard normal distribution. So there's like 4 types of problems, because I could say if it's standard normal, it's either a regular type of problem or it's a backward problem. If it's a normal distribution, it can be a regular type of problem where I ask you for the probability, or it could be a backward problem where I give you the probability. Well, the other type of problem, so there's those 4 types of problems, and then there's just that general kind of normal distribution using the 68, 95, 99.7% rule, which is what you're going to use here. They tell you the mean, they tell you the variable is normal, but they don't tell you the standard deviation. However, indirectly, they are giving it to you because they're talking about this. 97% of the observations are between these values. So from there, you could sketch it. Remember, you're only supposed to ever sketch the standard normal when you understand or when you interpret a normal problem. It's only in the case where I talk about the certain thresholds of 68, 95, and 99.7% that you will draw this out. Okay, so you can actually sketch this. So it's between 5.5 and 8.5 that there's 99.7. So that means 5.5 and 8.5, right? You're told that that's 3 standard deviations away because they told you that that's 99.7% of the observations between here and here. So that's supposed to be from here, the middle. That should be 3 standard deviations here. So can you guys think about this? What is sigma? Why do I care? Because, because the question is now going to ask me about these values here, 6 and 7.5, and I need to find out if that is going to fall, you know, at these markers of 68, 95, and 99.7, or if I actually have to do this by standardizing the problem. Okay, so let's just draw it to find the standard deviation because that's a missing piece of information. Once you know the distribution, the type of distribution, as long as you are given the mean and the standard deviation for the normal, those act like parameters. Just with those pieces of information, it's complete. In other words, you're able to make estimates of what to expect. So let's get back to that drawing. I hope I saved it. There it is. So, are you not seeing my drawing yet? So much of a delay here. I have to get used to it. Alright, so here the mean was, oh, now I gotta go back again. What was the mean? The mean was 7. So 7 is in the middle. And so between here and here are 3 standard deviations. Okay, so between here and here are 3 standard deviations. So that means that there's 1.5 is equal to 3 standard deviations, right? You guys see that? So then the standard deviation is equal to 0.5, that's right. So standard deviation is equal to 0.5. And now, the question was about 6 and about 6 and 7.5. So if I go over by 0.5, that's 1 standard deviation. If I go over, that's 6.5. .5 would be here. That would be 1 standard deviation, and then 6 would be 2 standard deviations, and 5.5 would be 3. So if we're figuring this out between 6 and 7, you can actually do this without doing anything fancy, right? You can figure that out. That's just this. And how much is that? I give you 2 minutes. the question was to find it between 6 and 7.5, so I have to actually go a little bit over. But that's fine, I can do that. That's going to be here 7.5, another standard deviation. And I know what that is too, so I can just add that in. Alright, so I know that this, between here and here, that's 2 standard deviations. So 2 standard deviations, the whole thing should be 95, but I didn't go that far. I just went half. So this is 95%. Oops. Divided by 2. But then you have to get this little piece in here. So this could be, and you could do this different ways. I'm just doing it this way. It was immediate. So then 0.68 divided by 2. And add those together. Because the question was between 7 point, I should write that down, 7.5 excuse me. Oh, I don't want to, I just want to delete this equal sign. Not easy. Anyway, ignore that. Okay. Any questions? So you're going to get whatever that is. $81.5. Does anybody get that? That's a percentage. Yes. Very good. Did you follow that? If not, you can review it. You can review the video. Oh, Marlene got something different. Did I do something wrong? Let me see. Let's look again at that. Okay, you got 81.5, Marlene. All right, so the answer is A. Okay, so that was a little bit different. That was like one of the problems, like I said, just working with the theory of, or the knowledge that the normal distribution has a property that 68% or most of the observations are 1 standard deviation from the mean. Almost all of them observations are 2 standard deviations from the mean, and then just because there's going to be 0.3% outliers, 99.7% of the observations are 3 standard deviations from the mean. All right? Okay, what next? Let's see. So this problem, the next one, Chloe, you just got half of it. Chloe just got half. You just got this half. Here. That's 47.5, but the question asked, and I didn't notice at the beginning, goes up to 7.5, so you're actually going 1 more standard deviation this way. So it's 47.5 plus 0.34 to give 81.5. All right, so this next problem Let's just look at a few of them and discuss what kind of problem they are. Okay, so this next one is about the standard normal distribution. And they just ask you find the probability. So this is a basic problem. Well, maybe not, because you have a little thing here you got to figure out. But it's basic in the sense it's not a, it's actually it's a backward problem, isn't it? Because you have the probability and you have to find the z. So for this one, you draw it. Should I give you some time? Give you a little bit of time? Draw it out. Give you 3 minutes for this. Hello, I'm back. How did it go? I don't know. The chat, I have two computers. I have the chat on one, and I have the chat live streaming as though I'm a stranger outside of my account, and it looks slower. So I don't know what to do. I just keep talking, and eventually I see the messages coming up. So sorry about the delay. I'm not sure how to master that. And it's different delay every time, so I haven't really pinned down how many seconds I should wait. Well, anyway, so let's see. For this problem, draw a picture. So let's draw a picture. Always draw a picture. So the numbers are 2162 and 117. So I'm going to add in a blank page. I'm going to draw a picture. And it's Z that we're talking about. Now, between little z and 1.17. So 1.17 I know is here. Seriously, I don't know how to do periods there. 1.17. And then the little z is somewhere to mark little z hits somewhere such that this is 21.62. Now, note I'm unsure if it goes here before the 50% mark or after the 50% mark. So the most important thing to do, let's do this. Let's divide, this is my instinct, tell me what this area to the left of 1.17 is. I'm going to save, well, I don't want to make me go out, right? So let's see, that's 1.17, let's go to the tables. 1.17, oh, just the answer, this, I didn't put the tables on this. Okay, someone's going to have to tell me. I'll get it on my other computer. Uh-oh. I can't talk right now. It was a call. I guess I could find out what time it is by telling you the time now, and you tell me when you get the delay. But okay, we'll worry about that after. I'm just getting, so if Z is 1.17, it should be more than 50%. Okay, everyone's telling me? Okay, so it's 8790, very good. So you just looked on the table for 1.17, and so you're on the positive Z table, or you did it in Excel. It's fine if you use Excel, if you know how to use it. And just checking the table, just checking the table. Yeah, I should trust you, I know, but I don't double check. 1.17 is 0.8790. You are correct. So this is 0.8790. So 0.8790 to the left. And now between here and here, between the middle and there, then minus 50, this area is 0.3. You guys see that? So this area here should be 0.8790 minus 0.5, so it's going to be 0.3790. So what is the number we're looking for? What's the magic number? We want to go to 0.2162. So that means that the little z is actually a positive number. Do I need to know that? Well, I really want to draw this properly, because if I draw it wrong, I'm going to have trouble. So that means little z must be here. I'll do it in the dark. So little z must be somewhere here, because remember, we're looking for an area between here and here that's 2162. So can you guys figure it out? Basically, you want to find this z here. Make it smaller. Are you following me? So this area here is 2162. Probably a better way to do that. And so if that's 2162, there's different ways to do this. There's a bunch of different ways to do this. But essentially, you just want to find out where z is. My drawing's bad, isn't it? It should be even. Make it thicker. Right, this area here. Are you working on it? Thinking about what to do? So it's quite easy if you just figure out, okay, if this is 0.2162 on this side, and the whole thing is 0.3790, all you need to get is this little red piece here. Let me darken this. So this red piece, what's this red piece? This red piece is all you need to add to 0.5, and that's what you do the backward problem on to find z. So, you know, this is all gymnastic. This is all exercise, right? The test is not going to be this challenging. These are all practice. These are the most challenging practice assignments, questions that I have for you. The exam's it's not going to be a bunch of hard problems. Okay? There'll be a mix of challenging ones, and you get to pick. You're going to be allowed to choose 30 from 40, just like these tests are. So identify what you're good at and what you're not good at. Yes, Malin, you might not have felt like you could have done this by yourself, but now you have an idea, so keep practicing. You know, you still have a few nights before Thursday, and just keep practicing. And you get to use all your notes, and you get to have all your stuff, so organize yourself. So then, this extra little piece here then, let's see if I can do the math, is 0.3790 minus 0.2162, and that's the extra little bit. So what's that? 0.790 minus 2162 equals 0.1628. So now, let's redraw this. Let me shrink this. Shrink this so we have it there as a source, but make a new drawing. Okay, this is not good. Make a nicer one. Smooth, I have to be light. And I basically want to know what the Z is here for this area to the left of, that's 0. The area to the left of that is 0.6628. You're going to see how easy this is now that you have the answer. So now, remember, this is a backward problem, and you have to look inside and out to find the Z. So 6628, why did I have 6628? Because I took this amount here and I added this. This is all 0.5. This is 50% on that side. So to find the area to the left of that is 0.6628, and now I can find the Z. So look inside the table, the positive table, because it's above 0, and what do you get? So look inside the table for 0.6628. You know, you could probably find a calculator online too if you don't want to use Excel. You guys can explore like a Z-score calculator, a quick Z-score. They do backward problems. I don't know. If you don't want to waste your time, don't bother. But if I put in this calculator that I found, 0.6628, because, you know, the tables that you need to know the table. However, since we are in these bizarre circumstances, yes, Heidi got it right, 0.42. Since we are in these bizarre circumstances, it's exciting to try and find whatever we can to make life easier. Okay, so that is the answer when you look it up inside. I will save that. I didn't keep track. Marlene, why do you have 0.98 negative? See if I can get a version of the table. Do I have a version of the table? There should be a table in one of the exams. There we go. So you were looking for the number 66, the number 6628. Okay, so you go to the positive table because you know that it's right up to the 0, and you look around and you make this bigger, and you look around, whoops, and you see 0.6628 is here, so the value is 0.42. All right. Okay, do I continue? Oh, it's 12 after 6. One more problem? Another NOR? I'm doing some oddball ones, right? A little bit different. All practice. Let's do something straightforward. I don't know. I think you should use this time to do the challenging ones, and then you can do all the straightforward stuff, following the videos and following through the notes. So I was doing rewrite. More NOR. Okay, back to NOR. Oh, 35 is another one. Okay. I'm just reading the problems. Marlene, 0.1628. No, Marlene, that's not what we're looking for, because we are trying to find the z. Let me go back. We're trying to find the z between, let's go back to the question. The question was asking about this region, 0.2168. Now this region is in black. This is the 0.2168. I had this information about this, but on this side I know the right end, but I don't know the left end. And how am I going to find the left end? How am I going to find the z for the left side? The only thing I got are these tables that give me the right side, the area on the right. So it's not going to talk about this little piece here, this little red piece that's left over. So I'm just going to add it on to the 50%. And it's like 0.500. And I'm going to add on the red area, and that will help mark this area. I mean this threshold. So that's why it's 0.6628 that I'm looking for. All right. Okay, let's see. Well, you know what I'm going to do? For tomorrow, I'm going to let you guys go, because you guys got to do more practice. So let's let you go and work on this exam for tomorrow. All right? So this is the, what did I call it? The rewrite exam. Just an hour together, just to get you motivated. Don't get exhausted. I don't want to exhaust you. This doesn't have, so this is the exam. This one here. Okay, October 26th. October 26, 2019. It was a rewrite. I let the students have a makeup test because they were so anxious. I wanted to calm them down. And they did well. They did well on this test. You'll be surprised. Practice does perfect. All right? So keep it up. Work on this one. You can ask me questions tonight. I should be on my computer. If I can guide you in the right direction, or you can hold out for tomorrow. Send me all your questions for tomorrow's stream. I will see you at 5 p.m. tomorrow. Check out the description where I have the timestamps, and you can review what we just discussed here. All right? So good night. Is that all right with everyone? Aw, Marlene. We'll see you tomorrow. Any comments? Any other comments? So the test will be on Thursday. It will be 2 hours available to you. You'll have to answer 30 questions of your choice out of 40. Know your strengths, know what you're good at, and use these exercises to hone your skills. See you tomorrow.